Lesson number 68 is more on complex fractions, and our problems are going to look like this. We're going to have to simplify fractions divided by fractions, and this time we're going to be adding fractions together or subtracting fractions, possibly even multiplying and dividing fractions before we find our answers. So in this problem, what we need to do is simplify as much as possible. So when we do that, we know x over y plus 1 over y. They both have the same denominator of y, so we could rewrite the denominator is y, the numerator is going to be x plus 1. The simpler we can make these by joining our terms together will make it easier to find our answer. Then we've got, well, both our denominators are y, so we're going to have y, and then we're going to say x minus 1 over y. Now here we're dividing our fractions. We've got x plus 1 over y divided by x minus 1 over y. Now sometimes it's easier to take these and look at them horizontally. So we can say x plus 1 over y divided by x minus 1 over y. We know when we divide fractions we just have to copy dot flip. So we're going to get x plus 1 over y times y over x minus 1. So you can see now it works out well because we know we can simplify before we multiply, and y divided by y is going to cancel because they're the exact same thing. X plus 1, well, y over y is the same thing as 1 over 1. So we've got our answer. Our answer is going to be x plus 1 as our numerator over x minus 1 as our denominator. And we've got our final answer. We can't simplify that anymore until we know what our x value is. Let's look at another complex fraction. Here we have 1 over x all over 1 minus 1 over x. Now with this problem, the numerator looks pretty simple already, 1 over x. We're going to divide it by, well, this one we can't simplify yet until we make both of the denominators the same. So we're going to have 1 over something minus 1 over x. Well, the denominators are going to have to be x. So I'm going to make the denominator x, and I'm going to multiply the top by the same thing that we did to the bottom. Because this was really originally 1 over 1, because that's the same thing as 1. So when we go through this process, we're going to rewrite, and we're going to get 1 over x, and we're going to divide it by x over, well, we've got x over x minus 1 over x, and we can simplify from there. When we simplify from there, we're going to get 1 over x, still as our numerator, divided by x is the same, so that's going to be our new denominator, and we've got x minus 1. So we have 1 over x divided by x minus 1 over x. Let's take the time to look at this one horizontally. 1 over x divided by x minus 1 over x. Now we know when we divide fractions, just copy dot flip 1 over x times x over x minus 1. And it works well to look at it horizontally. It makes it easy to see what's going to cancel out. We can see that x over x, or x over x, is going to be the same thing. That's 1 over 1. So we've got our answer now. These complex fractions, they're really not so complex when you take them one at a time. 1 times 1 is 1, and 1 times x minus 1 is x minus 1. So we've got our final answer, 1 over x minus 1. We can't simplify that anymore, so we can move on to our next question. We've got one more today. Here we're going to simplify. And this one has negative powers, but don't let that intimidate you, because you know how to work with those. In this problem, our numerator is going to be, well, it's a to the negative first over x, but let's make it x over a to the first power, because we just moved this into the denominator in order to get rid of the negative power of 1. So we've got x over a as our first part, plus, and then we're going to have y over b. And that would be y over b to the first power, but we don't ever have to write to the first power, that's implied. That's our whole numerator. We have x to the negative first power, which is really just 1 over x. And now we can solve. In order to solve this one, let's work with what we already have. We need to have the same denominator. So we're going to have to multiply the a times the b. and then we multiply the numerator times b. Then we've got b. Well, we need ab, so we're going to have to multiply the b times an a. And we're going to multiply the y times an a as well. And now we can simplify. We can see that our numerator is going to be a denominator of ab. And our numerator of our numerator is going to be xb plus ay, because that's what we have right here. That's all going to be divided by 1 over x. Now, don't let this fool you. This is just division of fractions. So we're going to get xb plus ay all over ab. And we're going to take it horizontally so it's easy to see. And we're going to divide it by 1 over x. Now we have to copy dot flip to solve. So we're going to get xb plus ay over ab, copy, dot, and then flip, so multiply by the reciprocal, that's x over 1, and now we can find our answer. We're going to get xb plus ay all multiplied by x, and our denominator is going to be ab. Now when we're here, we've got an option. We could use a distributive property to multiply through, or we could leave our answer like this. This is one potential answer. This one would get you full credit. If we use a distributive property, well, x times xb, that's going to be x squared, and then we're going to have b, because x times x is x squared, then we multiply the b. Then we get plus xay all over ab. We can't simplify that, so we're all done. This would be another possible way to report your answer. Both ways are correct. Both ways will get you full credit. And if we look back at our textbook for this one, the answer is reported like this, our first one. And I would encourage you to report it that way too. That's what we get originally, and it's a little bit simpler because we've factored out the x. But again, this would be your choice on this problem. Lesson practice will be on page 278. Make sure you've got your notes complete, and I'll see you during our next class.